class. Today we're going to talk about ellipses. An ellipse is the set of all points, so all the points all around here, whose sum is this xy distance from the foci. So the vertices are these 2 points that are at the end of what's called the major axis. So the major axis is this chord joining the 2 vertices. The center is the midway point between the 2 vertices, and the distance from the center to the vertex is what we call A. So from the center to the other vertex is also called A. The minor axis is the shorter axis, and you have the co-vertices, or the endpoints of the minor axis. And these 2 axes will be perpendicular, and they will go through the center. So some other distances we have is the distance from the foci to the center is called C, and then the distance from the center to the co-vertices is B. So we have, those are B, we have A is from the center to the vertex, C is from the center to the foci, and B is from the center to a co-vertex. And then you have the symmetry. For ellipses, we have a horizontal ellipse where the major axis is horizontal and the vertices in the center and the foci lie horizontally, or we have it when it is vertical. So if the major axis is vertical and the vertices, the foci, and the center are on a vertical line, then you have a vertical ellipse. In standard form, A is going to be bigger than B, and both of those numbers are going to be bigger than 0. A is half this length of the major axis, and B is half the length of the minor axis. So A will be bigger because it's longer, and B will be shorter. So that's what we're saying here. So we have 2 standard form equations. One, if the major axis is horizontal, the bigger number is under the x because it's going to be longer in the x direction. And then when the major axis is vertical, the bigger number A is under the y because it's longer in the y direction. We have again that the center is going to be HK in both of those. So the eccentricity is going to measure how oval is it. Is it going to look very oval, or is it going to look more circle? So to calculate the eccentricity, you just take your C and divide it by A, and that's the formula for eccentricity. And my eccentricity will always be a number between 0 and 1. For an ellipse that is nearly circular, the foci are going to be close to the center, and then the ratio C over A is close to 0. So the eccentricity is going to be close to 0 if it's nearly circular, but on the other hand, for an elongated ellipse, if it's very oval, the ratio C over A is closer to 1. Sometimes in a problem, we might be given just 2 of these 3 values for A, B, and C, and we're going to use this formula, C squared is A squared minus B squared, in order to solve for the 3rd variable. So we need to memorize that. And then if your ellipse is really a circle, then your A squared equals B squared. Your A, which is this distance, is going to equal your B, which is this distance. So if they're the same, then you really have a circle. So your A squared and your B squared are the same, which you can write as one fraction, or you can multiply your A squared to the other side, and this is really just the equation for a circle with A instead of R. The point being, if A and B are the same, then it's a circle, a very special ellipse. For example 1, we're going to find the standard form of the equation of the ellipse with the foci here and a major axis has length 8. So first we have to determine, is it going to be the vertical ellipse equation or the horizontal ellipse equation? So let's start by plotting these 2 points roughly. So I have 0, 0 as one of my foci, and I have 4, 0 as my other foci. So I know that the foci lie on the major axis. So this tells me that this here is going to be my major axis. So my major axis is horizontal. So since the major axis is horizontal, I know I'm going to use the horizontal formula, which is x minus h squared, and I put the larger number a squared under my x, plus y minus k squared, and then the other number b bottom, and that's going to equal 1. So I have to find the center. So I know that the foci lie equidistant from the center, so my center is going to be in the middle. I can't use C for center because we're using C as the distance from the center to the foci is distance C. So this is at 4. I know my center, which I'm going to label as Z for center. It stands for the German word for center. So if the foci are 4 units apart from each other and they are congruent, then my Z is at 2. So I know that my center is the point 2, 0. So I have my H and my K. So I can plug those into my formula. So I have x minus 2 squared over something, we'll get back to that, and y minus k, which is 0, squared over something equals 1. Of course, you don't have to write y minus 0. You could just simply write y squared as such. Either way would be acceptable. Okay, so let's talk about how we find our a value. So we know that the major axis is of length 8. So from the center to the vertices, I know the vertices are going to be outside of the foci. This whole distance, the whole distance from vertex to vertex, is the major axis, and its length 8. And I know it's going to be split equally in half. So I'm going to have 4 on that side and 4 on that side. So from the center, which is at 2, I'm going to go 4 units out to 6, and I'm going to go 4 units the other way to negative 2. So I know my vertices are at negative 2, 0, and at 6, 0. Because the major axis is length 8, the major axis goes from vertex to vertex, so that whole length is 8, so half of it is 4 from either side of the center. So if I go 2 plus 4, I get 6, and 2 minus 4, I get negative 2. This also tells me that the distance from the center to a vertex is your a value. So I know my a equals 4, because either distance from the center to a vertex is 4. So my a equals 4, so I have 4 squared there, and I'll eventually write it as 16. So now what I need to do is I need to find my b value. That's where we're going to use that formula, the a squared minus b squared equals c squared. And I'm going to plug in a squared is 4 squared. I don't know my b squared, but my c was the distance to the foci from the center, which is 2, so it's 2 squared. So I'm going to add b squared over here. I have 16, and I'm going to subtract 4, so I get 12. And I'm going to take the square root of that, and I have 2 root 3 is my b, or my b squared equals 12, and what goes down here is my b squared. So my equation is x minus 2 squared plus over 16 plus y squared over 12 equals 1. And that is the standard form of the ellipse. So in example 2, we're given the equation that's not in standard form, and we're asked to find the center of the vertices, the foci, the eccentricity, and then sketch its graph. So to do any of these things, we first have to put it into standard form. To put it in standard form, we have to complete the square. So to do this, I'm going to group my x's. I'm going to rearrange it so I have an at my x squared, and then my x term, and then I'm going to lose some space, and then my y squared, so 4y squared, plus my 20y. I'm going to group my x's together, and then group my y's together, with a little bit of space. And then I'm going to take my constant 2 and add it to the other side. So in order to complete the square, for this one, there's no coefficient of x squared, so it's just x minus, you take half of that number, which is 3, and you square it, and then you square it up here, and I added 9. So I added 9 to this side, so I have to add to the other side. For the second one, we have this coefficient of y squared. We can never complete the square when there's a coefficient of y squared. So I'm going to factor it out of both of these terms, whatever the coefficient is. I'm going to pull out a 4, I have y squared plus 5y, leave a blank. And my 2, this was, I added 9, so 2 plus 9 is 11. I'm going to leave a blank, because I'm going to add something here, and I'm going to add it here. So when I complete the square, I have my 4 on the outside of y. You take half of 5, and half of 5 is just 5 over 2. You square it, and then so you take half of that number, and then you square the number and put it there. When I square it, I square the top to get 25. I square the denominator to give you 4. So really what I've added to this side is 4 times 25 over 4. So what I add to the other side here is going to be 4 times 25 over 4. So whenever there's a coefficient, you need to make sure you multiply it by that number when you add it to the other side. This term still gets carried down below, so it's x minus 3 squared plus 4 times y plus 5 over 2 squared equals this number, which I'm going to simplify. The 4's go 25 plus 11 is 36. Now standard form typically is set equal to 1. So to do that, I'm going to divide every term by 36. Divide everything by 36. So my standard form equation is x minus 3 squared over 36 plus 4 and 36. Simplified, I give you 9 in the denominator, and I have left with y plus 5 over 2 squared in the numerator equaling 1. So here I have the standard form of the equation. Okay, so now that I have the standard form, I can find everything that we're asked to do and graph it. So I'm going to notice that the larger number is under the x here. So that tells me that the major axis is going to be horizontal. So I know that my a squared is 36, and here the smaller number is my b squared equals 9. So I'm going to use those two to find my c, using my a squared minus b squared is c squared. So a squared is 36, b squared is 9, and that's going to equal c squared. So when I subtract the two, I get that c squared equals 27, or when I square root it, this is 9 times 3, so 3 root 3. So I have my c values. If I plug that into my calculator, I know that's going to be about 5.2, and I'll need that for graphing, because that'll be the distance to my foci. So my center, I read off the values here. So my center HK is 3, comma, and then negative 5 over 2, or negative 2.5. Fraction or decimal would be appropriate. So I'm going to plot that. Center is 1, 2, 3, up 1, 2, and a half. There's 3, negative 2.5 down here. I know the major axis is going to be horizontal, and my a squared is 36, so my a is going to be 6. So from that, I know the center to the vertex is 6 units, so I can count 6 in either direction. 1, 2, 3, 4, 5, 6. And there's one vertex, and then I'm going to count 1, 2, 3, 4, 5, 6 in the other direction for the other vertex. Now I can plot my foci. My foci also lie on the major axis, and the center to the foci are 5.2 units. So I'm going to count 1, 2, 3, 4, 5, and a little bit more to give me my foci. And then 1, 2, 3, 4, 5, and a little bit more for my other foci. Remember, for the center to the vertex we added 6, so I know it's at 9, and we subtracted 6 at negative 3. So we have my vertices. To find the equation, or sorry, the coordinates of the foci, I went to 3, and then I added 3 root 3. So it's 3 plus 3 root 3, and I went down 2.5. And then here I did 3, and then I subtracted 3 root 3, minus 3 root 3. That's at negative 2.5. In graphing, we need to do the covertices. So b squared equals 9, so my b equals 3. So from my center up, I go 3 units to get to the covertices, and I go down 1, 2, 3 units to my other covertices, and now I can draw my ellipse. You can see I drew in my ellipse, and then I labeled my covertices values on the axes. There's no letter for the covertices. So last I need to find my eccentricity, which is c over a. c is 3 root 3, and my a is 6. I'll simplify with those 3's to be root 3 over 2. So the expectations for the graphs is you label the center Z, the foci F, the vertices V, and you label all of those key markings on your axes. Thank you.